Hey guys, it's Chris at Highline Guitars, and you're watching another episode of From the Luthier's Workbench. If you like to build or repair guitars, I suggest you click that subscribe button down below, and you'll become part of a community of fellow luthiers. And together, we can take your skills to a whole new level. If you'd like to support my guitar building YouTube channel, visit eguitarplans.com and buy a plan. A link is in the description below. Now on with the video. In today's episode, I'm going to continue with the making of my CNC pickup winder. But what I'm going to focus on in this episode is the front end. You see, when you use CNC technology, there are two phases of actually using the equipment. And this doesn't matter whether you're using a big CNC machine to cut out a guitar body or a 3D printer or something like this little CNC winder. The two phases are the front end and the back end. And on the front end, you have to use software. You're inputting data and ultimately writing G-code. And then on the back end, you're feeding that G-code into the CNC machine to make whatever it is you're going to make with it. In this episode, I want to kind of talk about my current front end workflow. And for those of you out there who are into software programming and computer workflows, you might find this kind of interesting. At any rate, I think it'll give you insight into how this project has progressed. So I wanted to document that. And I want to emphasize that what I'm about to show you it's a primitive and preliminary workflow. This is not necessarily what I would expect a person who would build something like this to actually use. Because I know that most people, when they use this sort of technology, they would like to have a simple to use software program that will handle the workflow and take care of that before actually using the machine. And that's ultimately what I intend to do. I intend to write a software program that will handle the workflow that I'm about to show you. However, for those of you who write software, you know how much work that takes and how, it takes a lot of brain power. It takes sometimes a collaborative effort, and it takes just a great deal of time and testing and trial and error in order to get it to work right. So before I took that leap, I decided in order to test the machine to make sure that it would actually work the way I wanted it to, I would put together just a really quick, simple, yet primitive workflow to help me test out the concept to make sure that I would get the results that I want. And so far, spoiler alert, it works exactly the way I want it to. So in this episode, I'm going to show you that front end, and then I hope in the next episode to actually show you a bobbin getting wound for a pickup. So let's jump on the computer and get started. Okay, so what I have here is a spreadsheet which I created on my Macintosh, and I'm using the Apple Spreadsheets program called Numbers. Although what I created here I could easily do in Microsoft Excel or Google Sheets. However, I have the program Numbers on my computer, so I just went ahead and used that. But if you look over at the far left side of the sheet, you'll see in column A, I have a number of fields where I can input the dimensions of a pickup bobbin core, and that includes the dimensions for the core height, the core width, and the core length. And I've already pre-filled these in with the dimensions for the bobbin that I'm about to wind. And then below that you can input, or I can input, the diameter of the wire that I'm going to use. And in this case, I'll be using 43 AWG wire. And the next field I have to fill in is the resistance in ohms per 1,000 feet. And what that is, that's a specification for the level of resistance per 1,000 feet for the specific wire gauge that I'm going to be using. Every gauge of wire has a different level of resistance per 1,000 feet. And you can usually find this by doing some research into the specific manufacturer who made the wire you're using, and they can tell you, they usually have a spec sheet which will tell you what the resistance in ohms is per 1,000 feet. And then down here at the bottom of the page, I created a little cheat sheet which includes that measurement for each different gauge that I typically use, which is 42, 43, and 44 gauge wire. So if I'm using 43, I just type in 2,143 ohms per 1,000 feet. And then below that, I have what is called the target resistance in ohms. And what that is the level of resistance that I want the finished coil to measure at when it's finished being wound. So I can measure that with my resistance meter, and it should, or what I'm targeting is 5,000 ohms for that finished coil. Now the coil perimeter, this is a little bit complicated. What it is in simple terms is the perimeter of the bobbin's core with what's known as fill factor added to the formula. And what fill factor is when you start to wind a coil, the length of the wire that it takes to make one full turn is, as an example, say 4 inches. However, by the time you get to the final turn, because the coil has grown in size, the length of wire needed will be approximately 5 inches. So it will increase by about an inch. So I've included fill factor into this formula to give me what I call the core or coil perimeter. And then to calculate the turn counts, it involves a math formula which involves the resistance in ohm per 1,000 feet, the target resistance, and the core coil perimeter, and I get 5,225. So that's how many turns of wire I'm going to put on this bobbin. Now in the next column, column B here, this is what I call a G-code block. And there are 4 different blocks of G-code. Now this first block, block 1, is what my G-code will always start with. And it includes the G20 code, which tells my Gerbil software on the Arduino Uno that I'm going to be, the code that it's about to receive is in inches. And then G90 is absolute positioning as opposed to relative positioning. And I'm not going to explain that. That's take too long to do that in this video. But following that is M3S200. And M3 is the code to tell the winder to spin clockwise. The S is the speed, so it starts out at 200 RPM. And then the code that follows is the code that will tell the traversing mechanism to make one full traverse. And I define a traverse as moving from the flange that's attached to the winder plate out to the outer flange and then back to the start again. So that's one full traverse. And each one of these X numbers that you see are the coordinates that the traverse has to move to. And each of these coordinates is based on dividing the core height into 8 segments. So those segments become the coordinates. And then what follows is the F letter, and then the number 20 or 15 or 10. And what that is the speed that the traverse is going to move. So F is feed rate. And at the start, when it moves off the flange, it's moving at 20 inches per minute. When it gets out to 0.0625 inches, the speed slows to 15 inches per minute. Then as it continues, it drops to 10 inches per minute, and it will stay there as it moves across the center of the bobbin. And then as it begins to, and it will continue that way, and as it gets close to the outer flange, it speeds up again to 15 inches per minute, and then 20 inches per minute. Now you'll also notice that I've got that S number in a couple of spots here. And what that S number is doing is it's increasing the speed of the bobbin winder until it reaches 1200 RPM, which is the full speed. And then from there, it will remain at 1200 RPM all the way to the end of the winding operation. So what I have to do is I have to build a G-code file that's going to be long enough to wind or long enough to traverse the wire during the entire length of winding 5,225 turns of wire. And you can kind of get an idea of how long that's going to take by simply dividing the turn count by the RPM of the motor. So 5,225 divided by 1,200 is going to be roughly 4 minutes to wind this bobbin. So I need G-code that's going to last 4 minutes. Well, this first block of G-code only lasts about 2 seconds. So I need to increase that all the way out to about 4 minutes. And to do that, what I have done is I have created several more blocks of G-code. Now this first, or this second, it's in column C, block 2, is exactly the same as block 1. The only difference is I've removed the M3, S200, the G90, and the G20. I've also removed the S motor speeds, because once it hits 1200, it's going to stay that way all the way through to the end of the winding operation. So all I need is just the coordinates and the feed rates. And so this column is exactly the same as the first, just without those motor speeds. So what I'll do is I will copy this entire length of G-code here in this block, and I'll paste it after block 1. And I would do that until I have a file long enough to take 4 minutes. And if I were to do that with just block 2, the resulting G-code file would lay the wire down in a very uniform pattern. So if I wanted a scatter pattern, what I would do instead is I would copy and paste this block or this block. These blocks are all the same coordinates, however the feed rates have changed. In block 3 here, the feed rates are double what they are in block 2 and block 1. And then block 4 is a bit faster even than block 3. So by copying and pasting these in a random fashion after block 1, I can create a G-code file which is going to yield a scatter wound pattern. Okay, I realize that this cut and paste method of writing G-code may seem fairly primitive. However, what I have done is I've created an application on my computer using Apple's Automator program. And with Automator, all I have to do is double-click the application, and it's going to automatically build my G-code file. Pretty cool. The only thing I have to do is delete the extension .txt and leave the NC extension, because that's the extension that G-code, it's the G-code extension that the Arduino Uno with Gerbil will recognize. So at this point, all I have to do is, well, I'll show you what this looks like. This is the file that I've created, and as you can see, it's fairly long. And what this is just a random mixture of those blocks of code, so that my traverse is going to speed up and slow down at random intervals as it's traversing the wire during the coil winding process. So that's how my current workflow is actually structured. Earlier I had mentioned that I'm planning to write an application which will automate the workflow that I just demonstrated. And this is that application right here. It's not finished yet, but essentially what this will do is function in a similar manner as that spreadsheet. However, it's hopefully going to be just encompassed into one simple application where you can calculate your turn count and then build your G-code file. So basically the way it works is I just input my dimensions for a bobbin core along with the desired or targeted resistance in ohms. And then I would select my wire gauge. And when I click calculate, I get my turn count. Then on the G-code builder side, I would, this isn't finished yet. I just have sort of started to plug in some concepts for how it's going to work. But, I could enter my winder motor RPM, which based on turn count would be able to figure out how long it's going to take to wind the bobbin. And then you could select a winding pattern from no scatter, which is uniform, minimum scatter, moderate scatter, or maximum scatter. And based on your selection here, when you click the button, it will write the G-code file that's long enough to traverse the wire for the full time it takes to turn the number of counts that you've calculated. And the way I'm envisioning this will work is you would, when you write that G-code file, you could save it to your computer, and then using Universal G-code sender, you would send it to the winder in order to wind the bobbin. Now, I'm sure some of you are going to wonder, well, why don't you just use this program as a G-code sender? And that's reinventing the wheel, because Universal G-code sender is a free program. It already exists and it has a lot of other features. So why build G-code sending functionality into this program when it already exists in Universal G-code Center? I know that means using two different programs, but it would save considerably on the amount of time it takes to code this little application. So that's kind of what I'm envisioning at the moment, and I'm building this in Python. And I've got it, I've got this part of it done, but this part I'm still working on, and this is going to take a while. This is going to be a real challenge to figure out how to build the G-code file. So I don't expect to have this done anytime soon. I'm hoping to have it done before 2022, but we'll just see how long it takes. But I don't want to put my CNC manual out there for the winder if there's no software available to run it, because trying to use that spreadsheet to build your G-code files, I think it's going to be more than what most people are willing to do, and it just isn't going to work well. But this should, if I can get it to work right. So once I have this part of the puzzle finished, then I will put the whole thing together as a package and make it available on the eGuitar Plans website. So stay tuned for that. Okay, well, that's all the time I have for this episode. And if you managed to make it through it, congratulations. You have more patience than Job. Anyway, in the next episode, as I said before, I'm going to demonstrate this machine actually making a pickup, which I think you'll find interesting. And if you've got any ideas or suggestions on how I could write the G-code for that program, how I could build that functionality into that little application, post it down below. Any links to potential research or anything like that. I've already got an idea of how I'm going to do this in my mind. I'm kind of putting it off a little bit because it's going to be massively time consuming. And I think once I get rolling into it, it should go okay. But I have a feeling that there are other people out there who've already invented that wheel. So, if you know of any other possible examples, let me know. And as always, if you enjoy videos on building guitars, making CNC pickup winders, making big CNC machines, click that subscribe button if you're not already a subscriber. Hit the bell for notifications so that you will get an email every time I post up a new video, which is a couple times a week. And as always, if you would like to help support this channel and what I'm doing here, head over to eguitarplans.com and purchase a plan either for one of the guitars that I've designed or the tools that I've made, which include the CNC machine, winder number 5, which is still up there and will stay up there, and all the other tools that I use. And in the meantime, take care, stay safe, and I'll see you soon.